There we go. All right. It is, wow, it's November. Crazy. It is 11/4/19. Okay, so today we're going to be talking about direct and...
Hey, shut up. We're doing notes.
Shh. You just got recorded. Direct and inverse.
I'm only going to watch the video.
The variations. Direct and inverse variations, all right? So, we haven't talked about direct, but we actually have been talking about direct variation for a long time. Direct variation, as one thing goes up, the other goes up. For example, as things grow, as age progresses with trees, the older tree is, the taller tree is. Does that make sense? They're directly related, right? Even with us, by the time we're babies, to about 16, as the years progress, as the ages go up, the height goes up. You guys get bigger. That's a direct variation. So direct variation is in the form of y equals mx plus 0. Now that should look familiar. That should look very familiar, okay? So that should be a straight line, right? It should be a straight line. And the book likes to use y equals kx, okay? So the value k is really like slope, but they're going to call it the constant of variation. So this k value is going to be called the constant of variation. Well, that's not too bad. In our case, it's basically the slope. So if you grow 3 inches every year, you go up 3/1, right? If you grow 3 inches every year, be up 3/1. That'd be a lot of growth. But let's say we grow. That'd be a lot of growth. Let's say we go 1 inch per year, right? Up 1/1, up 1/1, right? That's going to be directly related. As you get older, you get taller. Directly related. Got it? Makes sense. Directly related, okay? Now, the big thing is this plus 0, okay? It must go through the origin. And I'm going to put that in a different color, okay? Absolutely must go through the origin, okay? So, okay, it must go, through the origin. Now the origin is the point 0, 0. So, as an example, I want to see a couple of graphs real quick so you can see how this works. So I want direct variation. Okay, watch these 3 examples. I just want you to watch. I'm going to do this real quickly with you. You don't have to write these down unless you want to. But let me give you 3 really pretty basic examples, okay? Okay, boom. Graph number 1. Is it straight?
Yes.
What's the slope? What's my slope? What's my slope?
1/2.
Yes, up 1/2, perfect. Does it go through the origin? This one is direct variation. Yes, it is direct variation. Okay, easy, right? It's straight, has a slope. The slope is 1/2 up 1/2, which is our constant variation. Same thing. Now, check this one out. Okay, the next 2 will probably be a no. I'm doing that on purpose. But let's take a look at this graph, okay? Okay. All right, check this graph out. Okay. Is it straight? Okay, look at my graph. Is it straight? Okay, it is straight. I like that. What's the slope? 1/2, but it does not go through the origin because you got to start at 0. To be directly related, you have to start at 0. So you start at 0, right? And then you go up. So this one's no, and the reason this is a no is because it doesn't go through the origin, right? It does not go through the origin. It's supposed to go through right here instead. So no. And of course, let me give you one last one, which I'm pretty sure everybody will see it. Okay. it is getting bigger, right? As 1 gets bigger, but it's not getting bigger at the same rate, right? So it's not directly, in fact, this is a square graph, so this one's a no, because it's not straight. It has to be straight. So that was not direct variation, okay? Everybody thumbs up. That's pretty easy. It's just a straight line. It's just a straight line that goes through 0, okay? Direct variation. Now, the other one is one we talked about. In fact, I showed you Vicky's graph. Nice graph, right? And you guys did the same graph. That one's called inverse variation, okay? So it's how the equation x times y equals some number. We'll call it k, right? xy equals k. For us, on our first example, we had, in fact, let's see, do I have it around here somewhere? Probably. Yep. I didn't graph mine. Vicki, can I borrow yours again, please? You had such a nice job. Thank you. So we did this one, and this was an inverse variation because as one value got bigger and bigger and bigger, like 12 and 2 and like 24 and 1, the other got smaller, right? Or as one value got smaller, the other got bigger, right? This was definitely inverse variation. So the equation on this one was x times y equals 24. So the k is the number that they multiply to. And then we did the exact same thing, but on the negative, and our equation was x times y equals negative 24, okay? Thumbs up, this makes pretty sense. And the big thing is if you were to solve for these, or you could write as y equals k over x, right? If I just solve for y. If I solve for y, divide by x, divide by x. I think somebody said that earlier, divide by x. Who said that? Lily. Yeah, that was Lily, yeah. So, and then what we know is that Cookie Monster says what? What did Cookie Monster say? Can't divide by 0. So we know right here that x cannot equal 0. Okay? So now, determine if these are direct variation or inverse variation. So example 1, just looking at it, what do you think? Just looking at it. What is it? Don't let John do all the work. What is it? It's inverse. It is inverse. Isn't it exactly like our xy equals 24, but it's xy equals 12, okay? So this one is going to be my inverse variation. It looks just like that one, doesn't it? Doesn't it look like just like that one? X times y equals a number. How about example 2? Let's solve. So if I bring over the x minus x, I got a y equals a negative x plus 0. Okay. What kind of line, what kind of graph would this be? It's straight, right? It goes through 0, but it can be negative, okay? So yes, this is going to be direct variation. And the slope is negative 1, or the k value is negative 1. Nice job, Lily. This one's direct variation. Nice job. Pretty easy? Oh, example 3 is kind of confusing. Maybe I could fix it and make it look better. Or maybe I just leave it the way it is. It kind of looks like that form, doesn't it? Kind of looks like that. You've got a number over x equals y. Or I can multiply, right? I can multiply and rewrite as 5 is equal to xy. Definitely. I'd say that's inverse variation. Good. Awesome. And then example 4. Let's solve for y, okay? Let's solve for y. Minus 4. I got an x minus 4 equals 2y. Divide by 2. So I'll have a y equals, let's see, that's like a 1/2 x minus 2. All right, if I solve for y, it helps, okay? What do you think?
Neither.
Who said neither? Why? Why is it?
Because it doesn't go through the point 0, 0, but it's not inverse either.
Good. It is a straight line. It is, guys, it's a straight line up 1 over 2. It's straight. It's a linear. But it doesn't go through the origin. It starts at negative 4. Nice job. So it's neither or neither, however you want to say it, right? Awesome, Lily. Okay, now, how about example 5? Let's fix it. Okay, yeah, let's multiply by 4x. I agree. Isaac, great idea. Let's multiply by 4x. Let's bring that up there. Times by 4x times by 4x. So I get a y equals a 4x times a 12. Okay, so let's just make it look better. Make it look easier, okay? Y is equal to a 48x. That ought to help. What do you think?
Boom.
Direct. Because it's got the plus 0. Goes up 48 over 1. It's a straight line, right? Direct. I totally agree. Okay, does it seem easy?
Yes.
So sometimes we have to rewrite them in the form that works for us. Okay, turn the page. Okay. All right. Example 6. What do you think? Might be direct. Let's put some graphs down. Okay. So if it's direct, let's see if we can come up with the equation. Let's see if we think it's direct. Up by 2, up by 2, up by 2, up by 2. Goes up by 12. It goes up by...
Yeah.
Ooh, I don't think this one is. I think this might be a square, huh? This might be a y equals x squared equation. You guys see that? 2 squared is 4. 4 squared, 6 squared,
Yeah.
8 squared. So that's neither one of the ones we were talking about, right? Neither. Or neither. Except for spelling would really mess me up. That's why I got to say neither. Because if I say neither, I'll spell it wrong because I can't spell. I would because I can't spell. I know.
I know. You just did that.
Right. Okay, how about number 2? How about example 7? What's this one? What do you think this is? Inverse. How do you know it's inverse? Even more than that, Julia. Love it. You're totally right. Even more than that. What? You ready? Watch. Everybody watch. What's 1 times 5? 5 times 1. 8 times 0.625. Try to calculate. What's that? I would go along with 5 maybe. Let's double check it though, huh? Jay's going to tell us what it is. 5. What's 20 times 0.25?
5.
Hey, 50 times 0.1? So what do I have? I've got x times y equals what? Yep, there's my equation, right? So I would say that's going to be inversely, that's an inverse variation. Awesome. Okay, last but not least, here we go. Example 8. Well, x varies inversely with y. First of all, before I do a whole lot, let me go ahead and write an equation. Right off the bat, boom. I'm going to write an equation. The equation I'm going to write will be this equation there. Okay? Makes sense because that's where it says inverse variation. Okay? So I'm going to write, boom, right off the bat, I'm going to write, okay, x times y equals some value k. All right? But we don't know what the value k is, but we can find that pretty easily because we're given some more information. Okay? So if x is 2, when y is negative 3, what's the value of k? This is easy, right? Negative 6, everybody agree? So then k is equal to negative 6. Okay, now we have an equation, right? We can make our equation. Let's make the equation. Now I can do that because I know what k is. So instead of x times y equals k, we know what the value of k is, right? Instead of x times y equals k, we know what the value of k is. So let's rewrite this as x times y equals negative 6. Okay, that's my equation. Now there's one more piece. It's easy. Let's use our equation to answer this. So when x is 12, plug it in, and we'll get y, right? When x is 12, plug it in. So we'll have 12 times y equals negative 6. Divide by 12, divide by 12. And negative 6 over 12 is negative 1/2. Okay? Easy, right? Easy. Okay, so let me stop recording and I'll find the homework for you. I did hide it on purpose.